Hello class, in this video we're going to walk through creating a confidence interval about the mean for a large sample, and that is typically described as anything with greater than 30, where n, your sample size, is greater than 30. So that also applies to your semester project where you've gathered 50 pieces of data, and also creating a confidence interval for a proportion. Which would be right here. This is a formula to create or identify the margin of error for a proportion. And here we're identifying the margin of error for a mean. So let's walk through these two examples. A random sample of 35 first-year college students, 35 people were asked, so that is n, my sample size, were asked how much they spent on entertainment during the year. The mean was $825 with a standard deviation of $240. Construct a 90% confidence interval for the average spent on entertainment during the first year in college. So they're giving us a mean so that we know we are using this formula here. We are not talking about a proportion. We're talking about an average, which is $825. So we're looking for a 90% confidence interval. So to find the z-score to use, we just use our table and find 90%. So we're going to use 1.645 for our z. So E equals 1.645 times our standard deviation, which is 240, which is right here. And we are dividing that by the square root of n, which is the number of people that were asked, our sample size, which is 35. So we've just set up our formula to create the margin of error, and I'm going to use Excel to do the math for me. So remember, to do any math in Excel, you just start with an equal sign, and now it just works like a calculator. So 1.645 times 240. I'll just do that first. It'll make it easier. I get 394.8, and I'm going to divide that by the square root of 35. In Excel, there is a function sqrt for square root. And now I can just put my number in there, which is 35. And 5.91608 is the square root of 35. And now I'm just going to divide. I'm going to point to this cell. I'm going to divide 394.8 by the 5.91608. And I get a margin of error of 66 point, we'll just say 66.73. We'll round it to that. Once you have your margin of error to create your confidence interval, you subtract it from the mean and you add it to the mean. So our mean in this example was 825. So I'm going to take my 825 and I'm going to subtract my 66 point, well, I'll just point to that and then we'll round it to 2 decimal places and hit enter. And now to create the other end of our interval, I'm going to take my mean and I'm going to add my margin of error. So my confidence interval is 758.27. I'm just rounding to 2 decimal places. And the upper limit is 891.73. So what this tells me is that with 90% confidence, I can say that all first-year students, the average amount that all first-year students spend on entertainment is between $758.27 and $891.73. One more thing, as opposed to doing this manually, which is what we did with this formula right here to come up with our margin of error of 66.73, you can also use this function in Excel. So to do that, I'm just going to start with an equal, and I'm going to start typing it in, and you see it. I'm going to double click on it, and the first thing it asks for is alpha. In Excel, alpha is 1 minus the confidence that you want. It's really your error percentage versus your success percentage. So if we're looking for 90%, which is what we are in this example, we're going to type in 10%, which is 0.1. If we were looking for 95%, confidence, we would type in 0.05, which is 1 minus 0.95. So my alpha in this case is 0.1. My standard deviation is 240. And my sample size is 35. And I'm going to hit enter. And you can see we get 66.73, slightly different, 66.727, but if we round it 66.73, which is what we got here, if we round it 66.73 is our margin of error. So you can do it manually this way, or you can use equalconfidence.norm. Okay, well, let's go on to the next example. The Paralyzed Veterans of America is a philanthropic organization that relies on donations. They send free mailing labels and greeting cards to potential donors on their list, and ask for voluntary contributions. To test a new campaign, they sent letters to a random sample of 100,000. There's my N, my sample size. They sent letters to 100,000 potential donors and received 4,781 donations. So out of that 100,000, they got a positive response from 4,781, giving 95% confidence interval for the true proportion of those who may donate. So they're looking for an interval, a range that we can be 95% confident that that percentage will respond to our campaign. So this is a proportion. We're looking for a true proportion, and here's the formula. Our z-score, or our z at a particular confidence level, times the square root of p hat times q hat. P hat is the probability of success. Q hat is the probability of failure. And we're dividing that by n, which is our sample size. So our probability of success is the 4,781 out of the 100,000. That is the percent that responded in a positive manner. So that is our success, which is P hat. I didn't put a little hat on it because I didn't know how. And we're just going to figure out what 4,781 divided by 100,000 is. And that's 0.04781. Q is the probability of failure. So that is simply 1 minus the probability of success. So I'm just using Excel as my calculator, 1 minus, and I'm going to point to this up here, and my probability of failure is 0.95219. If I add these two together, which I'll do just to make sure, I should get 1, which I do. So this is my probability of success. This is my probability of failure. So I'm going to multiply those two together and divide by n, and then I'm going to take the square root. So let's just take it one step at a time. I'm going to say P times Q, and I'm going to divide all of that by n, which is my sample of 100,000. And that's this here. Don't get nervous with that. That E minus 07 just means that we are moving our decimal place if we had to type it out 7 places to the left. But let's not worry about that right now. And we're going to take the square root of that number. So again, in Excel, I can say square root. And I'm just going to point to that and hit enter. And the square root of it is 0.000674716. And now I have to multiply that by my z with 95% confidence. So I just look at my table. It's 1.96. So I'm going to say equal 1.96 times, and I'm just going to point to this because that number represents my p, the square root of p times q divided by n. And this is my margin of error, 0.001322444. Let's just, we'll just round that to 0.001322. So that is my margin of error. Now, when we're talking about proportions and creating the confidence interval, we take that margin of error and we subtract it from the probability of success, and we add it to the probability of success. And this 0.04781 happens to be my probability of success. So in the low end, I am going to take this number and I'm going to subtract this number. And then on the high end, I'm going to take the probability of success and I'm going to add my margin of error. So if I were to write that out over here, that would be 0.04648, comma 0.049132. And it would kind of be nicer because we're talking about these proportions to put this in terms of a percentage. So I can just move the decimal place 2 to the right, and I could say 4.6488% to 4.9132%. So what that tells me is that when I send out my mailings, I can expect, or I'm 95% confident, that between 4.65, let's say, and 4.91% of the recipients are going to return a donation. Okay, hope that helps, and as always, reach out if you have any questions.